Hey everyone, welcome to this project walkthrough. In this video, I'm going to show you how I built an end-to-end taxi demand forecasting project using BigQuery, ML, and Python. We'll start from completely raw New York taxi data, aggregate it, explore it, build a time series forecasting model with ARIMA+, and then connect everything to Python to evaluate and forecast future demand. This project is also designed as a foundation for a future MLOps pipeline, so I tried to keep the structure clean and production-oriented. So let's jump into the BigQuery phase first. After creating my GCP project called ML AI Portfolio, I start in the BigQuery console. The first thing I do is create a new dataset called Taxi Forecasting. This dataset is basically the home for all the tables and models, and I'm going to use them in the project. At this point, the dataset is completely empty. No table, no data. In the next step, I start bringing the New York taxi trips data. The raw New York taxi data is trip level. Every row is one ride. That is great for detailed analysis, but for time series forecasting, I want something much simpler. Just one row per day with the total number of trips. So in BigQuery, I write a SQL query that reads from the public dataset, converts the pickup timestamp to the date, groups the date, and counts how many trips happen each day. Then I store the result in a table called Aggregated Daily 2022. This table is the backbone of the whole project. One date column, one trips column, ready for time series modeling. Before doing anything fancy, I want to double check the basic structure. I run a simple query to get the minimum date, maximum date, and how many days I have. The result tells me the data starts at the 1st of January 2022, ends at 30th November 2022, and there are 334 rows. That means the aggregation worked. I have one row per day and no missing dates inside this range. So the time series is clean and continuous. That's exactly what we want. Next, I want to see if there is a weekly pattern. I filter the data to only Saturdays and Sundays and look at their daily counts. When I scroll the results, I can already see that some weekends, specifically Saturdays, have a higher demand. Sundays are usually a bit lower. This suggests there is a weekly seasonality in the data. To make that weekly pattern more obvious, I calculate average trips per weekdays. The result is very interesting. Thursday and Friday have the highest average demand. Monday and Sundays are the lowest. Tuesday, Wednesday, and Saturday are somewhere in the middle. So the weekly patterns looks like high in Thursday and Friday, medium in Tuesday, Wednesday, and Saturday, and low in Monday and Sunday. This confirms that the data has a strong weekly seasonality, which is important when we choose our forecasting model. Now I plot the whole year from January to end of November. When you look at the chart, a few things stand out. First, there is very clean zigzag pattern every week. Peaks in the middle of the week, drops on the weekend. That's our weekly seasonality. Second, we can see a long-term trend. From January to around April, demand gradually increases. In summer, it's slightly lower. Then in September and October, it goes up again. At the end of the November and into December, there is a clear decline. Third, there are some sharp dips outliers. One near end of January, one around mid of July, one strong one around mid of September. These are probably holidays, extreme weathers, or days where the data is incomplete. But instead of deleting them, I let ARIMA Plus handle them. Finally, I noticed that December is not fully populated in the public dataset. That is why I decide to train the model on January 1st to end of October, test the model for November 1st till end of November, and ignore December for evaluation. because the data is incomplete. This EDA phase basically shapes all the decisions for the modeling. Now that I understand the data, I move on to the modeling phase. I use BigQuery ML and create an ARIMA plus model called Daily ARIMA model. So BigQuery will detect weekly seasonality automatically, try different ARIMA orders such as P, D, and Q, handles spikes and dips, and includes the US holidays in the modeling. The training data is from January 1st to October 31st based on our EDA decision. After training the model, I run ML evaluate to see the internal diagnostics. BigQuery tries several ARIMA configurations, different combination of P, D, and Q, and for each one it shows the ARIMA order, whether the model has drift, the log likelihood, the AIC value, residual variance, detected seasonality period, and whether it has spikes and dips. BigQuery automatically picks the ARIMA Plus configurations with the best AIC for us. Next, I want to see how the model behaves on real unseen data. So I evaluate it on November 2022. I create a table called Actual versus Forecast November 2022. It has the actual daily trips from the aggregated table, the forecast values from ML forecast, and two extra columns, error and absolute error. This gives me one row per day in November with actual values, forecast values, the error, which is the differences between actual and forecast, and absolute error. This table is the base for computing RMSE, MAE, and MAPE. Using that table, I calculate three metrics: RMSE, which is root mean squared error, MAE, which is mean absolute error, and MAPE, mean absolute percentage error. The key metric here is MAPE, and it comes out around 16%. To interpret that, the daily demand is roughly between 90K and 135K trips. The average is around 115K. So with MAPE around 16%, it means on average the model is off by about 16% of true values. For this kind of noisy seasonality real-world data, under 10% would be very good. Between 10% and 20% is moderate but acceptable, and above 20% would be weak. So the ARIMA Plus model is a decent baseline. Not perfect, but a solid starting point. Once I'm happy with the baseline model, I connect everything to the Python so I can run forecasts from code, visualize results, and later integrate with APIs and MLOps. I create a virtual environment using Venv, activate it, and install the required packages from requirements text. Then I configure authentication with G-Cloud. I log in with the correct Google account, set the active project to ML AI portfolio, and set up application default credentials. This allows Python BigQuery client to talk securely to my BigQuery project. To avoid repeating boilerplate code, I create a small helper class called BigQuery client. It builds a BigQuery client, has a run query method that returns the raw result, and a toDataFrame method that directly returns the pandas data frame. This makes the rest of the code much cleaner. Every time I need the data from BigQuery, I just called BigQuery toDataFrame class. Next, I wrap up forecasting logic in a class called Model Predictor. This class uses the BigQuery client internally, run ML's forecast on my ARIMA Plus model, and returns a data frame with forecast timestamp and forecast value. I can pass the full model path and the horizon like 30 days or 60 days or etc. This allows me to run forecasts directly from Python instead of using only BigQuery UI. To visualize the model quality, I write a script that loads actual November data from BigQuery, loads the November forecast from Model Predictor, merge them on the data, plots them together with Matplotlib. In the chart, I see the model follows the overall weekly pattern quite well. But on some days, specifically around the middle and end of November, the actual demand suddenly drops. The forecast doesn't fully capture those sharp dips and stays smoother. This is typical ARIMA behavior. It's good at capturing trends and seasonality, but it's not perfect at sudden shocks like holiday or unusual events. Still, the comparison plot confirms the story from the metrics. The model is decent, it's not perfect, but it's good baseline and behaves reasonably for most days. As the final step, I use the same Python pipeline to forecast December 2022. I asked the model for 60 days of forecast. The first 30 days for November plus 30 days for December. Then I filter only the dates from December 1st to December 31st. The result is a full forecast for the whole month of December, even though the public dataset doesn't contain real December data. This is an example of true future prediction scenario, where the model looks beyond the historical data window and gives the unexpected daily demand. So that's the full journey of this project. We went from raw New York Taxi trips data all the way to clean daily time series in BigQuery, a baseline ARIMA plus forecasting model, proper evaluation with metrics and visualizations, and finally a Python integration that can forecast both test periods like November and future months like December. The code and structure of this project are also designed to plug into a future MLOps pipeline, where we can automate retraining, deploy the model behind an API, and serve prediction through Google Cloud Run or similar services. If you're interested in seeing the next step, turning this into a full MLOps pipeline with CI/CD and deployment, stick around for the next project in this series. Thanks for watching and see you in the next video.